Hello students, in this session
Let us solve a question on slope and deflection. A simply supported beam of length 2L is subjected to a moment m at the midpoint x is equal to 0. So we have a simply supported beam. It is shown here. Figure is also given to us. There is a simply supported beam. One is the hinge joint and one is the roller joint. And a bending moment is applied at the center. This point is the center point and m is bending moment is applied, and this is x is equal to 0, means the direction x is taken from this point, center point, this c point. This c point is the center point where x is 0, and x is increasing towards right, towards roller joint, right? And the deflection in the domain between 0 and L is 0, x and L is given by this equation. This is the equation is given of deflection. This W is here is the deflection basically, right? Here W we mean that this is a deflection. So in this domain means which I am making with red. In this domain, the deflection is given as W, right? W deflection is given, right? So, and E and I are given as Young's modulus and moment of inertia. We have to find out the slope at the center. What is the slope at the center? This we have to find out, right? So this is our aim, to find out the slope at the center. What is the slope at the center, right? So options are given to us and we have to decide the correct option out of these four choices, right? So let us solve this question.
this question is of slope and deflection question. We have a simply supported beam, AB is the simply supported beam, and a moment is applied at the center at a distance L from the one of the end, right? One moment is applied, and also the deflection equation for this part, CB part, this is valid for CB. For CB part is given by this equation, the deflection equation. Here W is given as deflection, right? And where X is taken from the center in rightward direction, right? So the deflection equation is given for this part only, CB part. We have to find out using these conditions, we have to find out the slope at point C. What is the slope of our elastic curve at point C? This we have to find out, right? Let us solve it. Now if we want to find out slope, then we have to use the deflection equation. We know the deflection equation is given by EI d2y by dx square equal to minus m. This is our deflection equation. EI d2y by dx square is equal to minus m. Here y is basically deflection, right? Y is deflection, which is here in the question given as W. So we can replace this y as W. So d2 deflection, this W is deflection, d2y which is d2w by dx square is equal to minus m. M at certain distance x. So now we have to find out so if we want to find out the slope, we have to differentiate it, integrate it once to get the slope, right? But here you should know the boundary conditions here. One of the boundary condition is there that at this point the deflection is 0. Another boundary condition is that the deflection at this point is 0. And also using this equation, you can see here that one more boundary condition we can find out, that you can see here that the x is taken from the center. At x is equal to 0, this becomes 0, the deflection is 0, right? At x is equal to 0, deflection is 0, right? So many boundary conditions you have obtained now, that at x equal to 0, the deflection equal to 0. This is first boundary condition we can use if required to find out the unknowns. When we integrate it, we will get the constants. So to solve those constants, we will be needing these equations. X is equal to 0, W is equal to 0, because we have put x here 0, and when we put x is equal to 0, W is equal to 0. It means there is no deflection at the center, right? So curve may be like this. There is no deflection at the center. At center point there is no deflection, so curve may be like this. At A point and at B point deflection is 0. So at x is equal to L, W is equal to 0, this is B point. At x is equal to L, B is deflection is 0, and x is equal to minus L in reverse direction, opposite direction. X is equal to minus L, again W is equal to 0. This is at point B, this is talking about point B, this we are talking about point A, and this we are talking about point C. So at 3 points A, B, C, the deflection is 0. And we have to find out the slope. These equations will be required to find out the unknowns when we integrate it. So we can integrate it. After integration you will get that EI dw by dx equal to integration of minus mx. But what is the value of m? Bending moment. Because this equation is given to us between C and B. So let us take a distance, a section here, x section here, right? And what is bending moment here? For that you should know the forces. Bending moment here is the sum of all the forces, sum of all the moments of the forces to the right or left of the section. But to the right of the section there is reaction. So we have to find out first the reaction, RA and RB. RA and RB. What is the value of RA and B? First we have to find this, and then we will be able to find out mx, right? So first we will find the reactions, right? So you can take the moment about A, and that moment about A should be equal to 0 for static equilibrium. So this implies moment about A, we have moment of RA about A is 0 because this RA passes through A only. Moment of RB and moment of M, both are anti-clockwise. So anti-clockwise can be taken as positive. So moment of RB will be equal to RB into 2L because total length is 2L, and the moment of M is, both are anti-clockwise, so both are taken positive. M is M because it is itself a moment, and that should be equal to 0. So RB will be equal to minus M by 2L. Minus M by 2L shows that the reaction RB is in opposite direction as that of we have shown here by the arrow, right? So we can make the arrow reverse here, so that RB value will come out to be M by 2L, right? So now it will become positive, right? Opposite to the direction as we have assumed earlier, right? So it is basically downward direction, right? And we know that there is no force is there, vertical force. So RA plus RB should be equal to 0 because there is no vertical force. Sum of all the vertical force should be equal to 0 using this. So there is only two forces, RA and RB equal to 0. So this implies that RA will be equal to, this is minus, so it will become plus M by 2L. So RA is M by 2L. So here RA is M by 2L. So we have found out the reaction. Now we can take in cross section X and we can find out the moment of this X about moment of this forces about X, right? So sigma mx will be equal to and X is taken from the center. So moment of X will be equal to force, that is RB, and it is negative RB multiplied by the distance, this distance, and this distance is, because we are taking X from the center, so this distance will be L minus X, right? So the perpendicular distance will be L minus X. So this will be RB into L minus X. So this will be equal to RB. RB is M by 2L. RB is M by 2L. So M by 2L into L minus X, right? Negative of this. So this is the bending moment at point X, that is M by 2L into L minus X. Now put this value in 1, the bending moment value in 1, what we are getting is, when we put here EI d2W by dx square will be equal to minus M and mx at a distance x. So this is this mx, so this is minus minus plus M by 2L L minus X. So we can integrate it to get the constant, and then the constant can be solved using boundary conditions. So integrating it let us have what we get. So that is EI dw by dx will be equal to m by 2l integration of this and this. So what we will get is, and or it can be further solved, that is m l to l cancel, m by 2 minus mx by 2l, mx by 2l. So integrating this, so what we are getting is m by 2, integration of m by 2 is m by 2x, integration of this is mx square by 2, so this is 4l plus some constant c1. Again integrate it to get the another constant. So we will get EI w will be equal to, again integrate it, so mx square by 4 minus mx cube, integration of x square is x cube by 3, that is 12l plus c1x plus c2. So this is the deflection equation, this is slope equation. Now we want to find out unknowns c1 and c2. We have the boundary condition that x is equal to 0, w is equal to 0. So we can write boundary conditions here so that we can solve this problem. X is equal to 0, w is equal to 0, x equal to L, w is equal to 0, x equal to minus L, w is equal to 0. These are the boundary conditions, right? I have written separately so that I can use this space. Now this is EIW, this thing. Now w is 0 at x is equal to 0. Put here x 0 and w 0. What you are getting? W 0, boundary condition 1 we are using. Boundary condition 1, x equal to 0, w is equal to 0. From here you will see that put here w 0, x 0, x 0 and x 0. You will get c2 equal to 0. So from here one of the constant is c2, which is equal to 0 we have obtained. Now another boundary condition is x equal to L, w equal to 0. We will be needing two boundary conditions only. So second boundary condition is x equal to L, w is equal to 0. Put here x equal to L, w equal to 0. So 0, which is left hand side is 0, right hand side is x equal to L, ml square by 4, ml square by 4 minus ml cube by 12l minus ml cube by 12l plus c1l plus c1l. c2 is 0. So ml square by 4, ml cube by l, 12l and c1l, and this is 0, right? We have put the boundary conditions. So c1 will come out to be, solve it and you will get the value of c1. So what is the value of c1? This will come out to be minus ml by 6. Minus ml by 6. This is the value of c1. So there were two unknowns, c2 and c1, and we have solved for c2 and c1 using the two boundary conditions. We have used two boundary conditions only. Third is not required, right? That at x is equal to 0, deflection is 0. At x is equal to L, deflection again 0, right? So we have used two boundary conditions to find out two unknowns, c1 and c2. Put here and you will get the, and put here value of c1, you will get the slope, because we have to find out the slope at c point, right? So put in this equation. Suppose this equation is slope equation. This is equation number 2. So put in equation number 2 and you will get the slope, right? So EI dw by dx. So what you are getting is EI dw by dx will be equal to mx by 2 minus mx square by 4l, mx square by 4l plus c1, and c1 is this value, minus ml by 6. Now we have to find out the theta, the slope at c point. So at point c, x equal to 0, put x is equal to 0 here, you will get the slope. So x 0 here, x 0 here. So what we are getting is, so dw by dx, which is the theta c, will be equal to 0 here, 0 here. So you will get minus ml upon 6 ei, minus ml upon 6 ei. So this is the slope, right? And in magnitude, if we see in magnitude, so theta, slope at C point is ml upon 6 ei. So this is the answer of this question. So this is the answer of this question, ml upon 6 ei, and this is option number C, option C. So option C is the answer. Option C is the answer. So this is how we can obtain the deflection at point C, right? We were given with a simply supported beam with moment. First we have found out the reactions. Finding the reactions, after finding the reactions, we have utilized this equation, deflection equation. Ei d2y by dx square is equal to minus m. Using this equation integrated 2 times, we have obtained two unknowns C1 and C2. These two unknowns are solved using two boundary conditions, because one of the boundary condition is given to us using this equation, which is given to us, that at x is equal to 0, deflection is 0, right? So deflection at x point is 0. We have used this, C2 will be equal to 0. Again boundary condition we have used that at supports there will be no deflection. So at x is equal to L, W is equal to 0. Use it and you will get a C1 value. Put this C1 value in the slope equation number 2 and you will get the slope with no unknown, right? And then because we want to find out the slope at point C where x is 0, so put here again x is equal to 0, you will get the slope at point C, which is ml upon 6 ei.